Hello everybody, I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that turn out the products we see around us every day. If you think you know everything about these things, you're in for a surprise. There's a whole world waiting for us to discover here on How It's Made. The topics today, nails and staples, safety glasses, fabrics, and bicycles. Toothpaste wasn't created yesterday. Thousands of years ago, Egyptians made theirs with pulverized pumice stone and wine vinegar. Happily, they've improved the formula. Today, there are still abrasives, but now it's water with added sweeteners, detergents, bicarbonate of soda for whitening, and delicious flavors. For connecting wood to wood, there's a great variety of fasteners. You can use common nails, spiral, finishing, even staples. See? We've got it all nailed down for you. There are hundreds of varieties of nails being made, and they're made of very durable carbon steel, all starting from steel wire. Rolled up on a drum, this steel wire weighs in at 2,045 kilos. The wire's diameter is 6 millimeters, and that's too large, so they'll have to reduce its size. Using many drums, they're going to pull the wire successively to gradually thin it. Then they'll roll it up again. When full, this roll will contain 23,500 meters of wire weighing 1,136 kilos. The wire now has a diameter of 2.84 millimeters, so it will have to be reduced by half. Now they're going to cut the wire into little rods. The cut rods are gathered up with this electromagnet and dumped into a machine that will process them. Here the rods are made into nails. The metal rods move along slowly and a blade forms the nail points. These blades are changed every 600 hours. This machine forms nail heads by flattening them with great pressure on the rod ends. Nail heads are formed at a rate of 1,400 per minute. The manufacturing of nails is now finished. They fall into a chute, then into this collecting bin. Nails are sold by the pound or embedded in plastic rolls, as we see here. This machine inserts 167 nails into each roll. The plastic strip has teeth, and the nails hook into these. They handle the rolls with gloves, since the coating applied to the nails is not yet dry. This machine produces 5 rolls a minute for a total of 835 nails. Making spiral nails requires an extra processing step. This machine puts the spiral into the nails with these cylinders and welds them. It makes 1,200 nails a minute. Then the nails are put together into strips for use in pneumatic nailing guns. Each strip contains 30 spiral nails. To help them stay in place, the nails are coated with a resin that dries in 4 minutes. This is the nailing device that uses nails on a strip. It sets the nails in one strike with the user's trigger finger. Now, we move on to the fabrication of staples. The staple press binds 80 iron wires which have been well lined up. The 80 small wires are placed side by side. The wires are glued together. Then the wires come out well adhered to one another. The staple strips are fed into this machine. It cuts the staples to the desired length and folds them in one stroke of this press, which applies 40 tons of pressure. Staples are formed on this gauge, and the staple strips are then ready for packaging. Every day, they produce a total of some 25 million nails here, which require the processing of 10,000 tons of metal annually. Things as diverse as using a drill or entering a small court to play racquetball can be hazardous to your vision. There's a simple way to protect your eyesight: with safety glasses. Many sports and trades require the wearing of safety glasses. These glasses are made by plastic molding. Here we see the interior of a mold. The optical part of the lens is mirrored in order to be as transparent as possible without being deformed. The glasses are made by melting the primary material, a plastic resin called polycarbonate. The resin granules are poured into this machine. It becomes liquefied at a temperature of 250 degrees centigrade. The liquid plastic is injected into the mold under pressure over a 30 to 60 second period. The plastic hardens rapidly, and the glasses are then removed from the mold. They mold several glasses at a time. The glasses are separated by hand and then are given an initial visual inspection. The glasses are placed on this support. They're then taken to the laboratory where they'll be given a surface treatment. But before beginning the treatment, they're washed to eliminate any impurities and to assure that the coating treatment adheres well to the lens. When they've been washed, the glasses are then rinsed in clear water. The glasses are now gently soaked in a chemical solution which prevents misting and scratching of the lens. This coating now has to be cooked. They direct the glasses towards an oven heated to 120 degrees centigrade. The soaking and cooking processes vary between 30 minutes and 2 hours. Each pair of glasses is inspected to make sure there are no imperfections or distortions in the lenses. Then the glasses are placed on this support. This milling machine automatically removes the last piece of polycarbonate. This one was left in place so that they could be able to handle the glasses without having to touch the lenses. At this stage of the production of the glasses, the nose piece is glued on. Certain pairs of glasses are selected from each production run. Here they evaluate the resistance of glasses to a racquetball hurled at them at 140 kilometers per hour. Here a hockey visor is tested against a puck traveling at 100 kilometers an hour. To conform to safety standards, the glasses must withstand these tests. It confirms that they're truly safe. They now proceed to final assembly steps in making the glasses. The last few pieces of the glasses, such as the plastic ear stems, are installed. Now completed, the glasses are placed in cases. It's the final step in their fabrication. They make several types of safety glasses here: industrial, hockey and football visors, swimming goggles, racquetball glasses, and for other uses. This particular facility can turn out thousands of safety glasses every day. And the polycarbonate resin used to make those safety glasses could very well save your eyes one day. Weaving mills make literally zillions of fabrics in every conceivable pattern and color. Great, but choosing exactly the right one, that requires some patience and perseverance. Fabric is made from thousands of braided threads. This mill has 700 bobbins of polyester. Each bobbin contains 250,000 meters of thread. We begin by separating the threads. This warp unit takes the 700 strands and assembles them. Then this comb separates them. Other strands are added, and in total, there will be 7,000 of them well aligned. One fabric is composed of threads braided at 90 degrees. The warp threads are assembled lengthwise, while the weft threads are joined transversely. To prevent the threads from tearing, they pass through a bin of glue. These rollers eliminate the surplus. The glue will be removed with water before dyeing the threads. The glued together threads exit this machine. These large green cylinders are heated and dry the glue on the threads. Knitting will soon begin. The 700 strands are newly separated on this loom roller. Each thread must pass through a blade to produce a specific design. This machine takes the 7,000 strands of thread one by one, and they pass through the blade. It's a highly precise operation. The threads pass through a blade, and the weaving finally begins. On this Jacquard-type loom roller, the warp thread is inserted by a jet of air. The weaving machine assembles two loom rollers made of 7,000 strands. The fabric reaches a width of 3.65 meters. The dark threads are inserted into the weave. They insert 600 weft strands per minute. The blades remove the weft strands to insert the warp ones between the two. A comb pushes the weft. The plate of the breakage chain stops the machine should a thread break. This bobbin contains 250,000 meters of thread. That's 250 kilometers. The weft thread is in the insertion nozzle. When a weft is inserted, an air jet nudges it in. The loom roller operates at full tilt. It makes 600 thread intersections a minute. Weaving is now over. We move on to the following steps: washing and dyeing. Washing is done in a soapy solution at 80 degrees in a continuous manner at a speed of 60 meters of fabric a minute. The fabric is rinsed in clear water of about 30 degrees. Now it's on to dyeing. This is done with jets. Up to 12,000 meters of fabric are placed in clean water into which colorants have been added. The solution is heated and the fabric soaks here for about 6 hours. Then it will be rinsed in lukewarm water. The fabric is placed in a bin. This machine is called an opener. It unfolds and stretches the material before rolling it up on an immense roller. And now the roll is almost full. We now move to thermosetting in a high-temperature oven which dries the fabric. The temperature is 200 degrees centigrade at the oven's entrance. The fabric circulates here for 45 seconds. This finished roll weighs 1,500 kilos. The bobbin that we saw at the beginning has produced 25 kilometers of fabric. Multiple gears, light but solid construction. From rugged mountain paths to quiet city trails, bicycles are built better and perhaps more popular today than ever before. A French invention of 1790, the first bicycle resembled a two-wheeled wooden horse without pedals or handlebars. In 1817, a German gave it direction control. The addition of pedals to the front wheels came from France in 1861. The British contributed as well, adding the large front wheel in 1870. By 1903, all countries participated in the first bicycle Tour de France. A bicycle is a beautiful piece of engineering. The frames are made of steel or a chromium molybdenum alloy known as chromalloy. Fabrication begins with these hollow tubes. The tube cutter cuts the steel before sending it to the bender. The bender curves the tubes cold, exerting strong pressure against the bending jig. The tubes must now be machined. That is, cut into lengths so that they correctly fit into one another. During this operation, cutting oil cools the tube. The tube is cut, taking into consideration the insertion angle of the other pieces. Tubes to be welded together are placed in this support. They insert a piece in an alloy of silver and bronze, which increases the strength and produces a better finish at the welding point. Welding now takes place. Welding of the frame requires about 2 minutes at a temperature of 800 degrees centigrade. Once welded, the part takes 4 minutes to cool. They proceed in the same way with all the tubes which form the frame of the bicycle. At this stage, it's important to straighten the frame, which could have deformed during welding. They verify the alignment of the tubes and they straighten it out cold with a tool that sets it to the right dimensions. Now they're going to paint the frames. Paint is applied with a spray gun and adheres to the frame by static contact. Then the paint will be baked in a natural gas oven at 218 degrees for 15 minutes. The frame is now cooled and we can begin the assembly. The labels are now applied. In another department, an employee assembles the handlebars. He installs the mechanism for the brakes and the gears. Now we move on to the wheel rims. The 36 stainless steel spokes of each aluminum wheel are installed manually. The dexterity of these workers allows them to install spokes on 65 wheel rims in an hour. This spoke tool allows them to screw the spokes into the rim. This machine exerts a pressure on the spokes so that they'll have the desired tension. If there's too much or not enough tension, the rim will be crooked. This machine aligns the rims, essential for proper functioning of the bicycle. It automatically adjusts the spokes so that the wheel will be truly straight. Next step, placing of the tubes and the tires on the wheel rims. Set upside down, the bicycle circulates from one workshop to another where they will install the last mechanical parts. These accessories are not made here. The handlebars, the pedals, the fork, the brake, and chain mechanisms are all installed manually. Here they screw on the rear brake plate. Finally, they inspect each bicycle to make sure that the bolts are well tightened and that everything's working properly. Then it's on to packaging. This factory makes 2,500 bicycles each day, assembled from various tubes of chromalloy. Each one weighs about 11.4 kilos and will run for thousands of kilometers. A picture's worth 1,000 words. I hope what we've shown you today speaks for itself. We wanted to take you behind the scenes into the world of manufacturing. I'm Mark Tewksbury. See you next time on How It's Made.